This puzzle is called X and Y by Jeet Sampat. I got it from the Sudoku Testing Submissions channel of the CTC Community Discord. Let's take a look at the rules. So the green lines are German whisper lines. What that means is that digits along there, adjacent digits along there, differ by at least 5. So if we realize that this must be a 2, let's say, then these 4 digits would all have to be digits 5 or more away from it. So like numbers like 7 or 9 or whatever, big digits basically. And obviously the opposite way, if we discovered this was a 9, then these would all have to be little digits. Digits 5 or more away. And then also there's the marked diagonals. We have the positive and the negative diagonal here, and digits can't repeat along this diagonal. So this is another set of the digits 1 to 9. Okay. So let's... Oh, I'll put a link to the puzzle down in the description if you want to give it a try. They said in the post, where is that? They said in the post it's a 2 to 3 out of 5 for difficulty. You can probably judge it a little bit better by the length of the video, maybe. And yeah, hopefully it'll be a good puzzle, I suppose. Because I don't know why. Let's just get going. Let's just get going. So the first thing I see is when you have an X like this on German Whispers, the middle digit must be a 1 or a 9. And same with over here. And let's just go over why that is. So maybe the first step is actually thinking about thinking about what adjacent lines are. And I kind of went over this in the rules or lightly mentioned this. So one digit, whatever this digit is, let's just say it's yellow. The next digit is going to be, if this is a low digit, let's say this is 1, 2, 3, or 4, the next digit is going to be a high digit, 6, 7, 8, or 9. And then the next digit is going to be a low digit again. You can't go from high digit to high digit because, of course, 9 minus 6 is 3, and the difference must be 5 or greater. So the way this is going to work out is that this middle piece is going to, this middle digit on the X is going to be adjacent to all the other digits, which means that all the other digits, the non-middle piece, must be of the same parity, either all high or all low. Now, let's just say these are all high. So this is 6, 7, 8, or 9. Now, what low digit is at least 5 away from all of these? If we tried to even make it a 2, then we couldn't put a 6 on either of these lines because the 6 would make it so that the 6 would break it because the difference between 4 and 6 is 4 instead of 5. So if yellow here is high digits, this must be a 1. If yellow is low digits, it must be a 9. That's just the way that works out, and the same goes for over here. And I guess, I don't know why I shouldn't have deleted that coloring. Let's do like this, I suppose. I guess that's fine enough coloring. Actually, no, let's do light blue and dark pink. So now this one over here is going to be the same situation. It must be a 1 or a 9, but of course it can't be the same 1 or 9. Like if this is a 1, this also can be a 1. That would be silly. So it's going to go like this. So this is going to be the, if this is a high digit, then this must be a low digit. And then, yeah, situated like that. So now, interestingly, these two, these are almost crosses, but not quite. Not quite. So this is a, let me think a second. Oh, okay, let's skip. I just saw something else. So where can 5 go on these diagonals? So one thing that I didn't mention about German Whispers, outright at least, is that 5 cannot go on a German Whisper line, because if we tried to put a 5 on here, the next digit would have to be either 5 less, which would be 0, or 5 more, which would be 10, and of course neither of those are possible. So 5 can't be on a German Whispers line. So where can it go along this diagonal? Well, it can't go up here in box 3, it can't go down here in box 7, it must be along here. One of these digits is 5. Well, let's look at the other diagonal. Can't be in box 9, it can't be in box 1, so it must be in box 5 again. So it needs to be both in yellow, and it also needs to be in hot pink. Well, of course, there's only one option for both of those sets. It must be right there. And let's just get rid of Oh, let's just get rid of the pencil marks now. So we have 5 in the middle. That's not going to be directly helpful, but actually it's going to be a little helpful. Where does 5 go in box 8? It can't go in a German Whisper, and it can't go in column 5 now, so we can pencil mark 5s down there. Then where can 5 go in here? Again, no German Whisper line, and can't go in row 9, so it must be here or here. And same but opposite for over here. So you get a little bit of information, but not a lot. Okay, so let's go back to these kind of crossy, almost crosses. T's that are falling over, maybe. Or somersaulting, maybe. Yeah, that kind of looks like a head and somebody somersaulting. So I'll go with T's that are somersaulting. So this can't be a 1 or a 9 because it sees both the high and the low digit. We don't know which is which, but we know one of them is the high one of them is the low one. So this is not a 1 or a 9. But it must connect to 3 of the opposite parity. So if this is a 2, this would be 3 digits that are 3 high digits. Similarly, if this is low, this is going to be sorry. If this is low, it would have to be a 2 in order to connect with 3 high digits. If it's an high, instead it would have to be an 8 to connect with 3 low digits. But unfortunately, we don't know whether it's high or low, and also we don't know if it's which one it matches. We don't even know if it's what colors are those? Light blue or dark pink. We do know these are opposite, and we know these will be opposite. What can we do with that? So let's just start coloring something. This is something. High or low. We don't know. These are all going to be opposites. Let's do hot pink, because green on green doesn't really work very well. If this is high or low, pink is the opposite of yellow. So now there's a pink and a yellow over here. So this must be a yellow, because we've already used the 4 pinks. There can only be 4 pinks in a box or row or a column. Okay. And then these are yellows or 5. And I generally do 5 as gray. Yeah. So over here, this 2-8 must be the opposite of this. So this must be hot pink, which puts yellows in the corners. Actually, I just had a thought. Well, let's finish up this first. So this must be like this, because this has 1 of each. We now have the 4 yellows in the box, so this must be a purple. So what I'm just thinking is, let's just assume for a second that this is 1. If we tried to make this 2 as well, could we do that? This is going to have 6, 7, 8, or 9. Let's just ignore this 8 for the second. 6, 7, 8, or 9. Then these are going to be 7, 8, 9. This will be 1, 6. So these 2 will be the same as these 2. Yeah, these 2 will be the same as these 2. This and the high digit will be the same as over here. For some reason, I thought that would break things open. Although, we do know this is not 1 and 2, I guess, because this 8, once we take this 8 into account, it's going to break the puzzle. And actually, no, the puzzle is broken right now, actually. I missed something. Okay. Again, just keep ignoring this 8. We don't need to worry about this 8. We'll just black it out for the moment. Even without this 8, this is broken. So we have, in this column, we have 6, and then 7, 8, 9. We have all 3 of them done. So 6, 7, 8, and 9 cannot be in these 3 cells. Let's gray these out. Also, in this in this column, we have 6, 7, 8, and 9. So in box 4, we cannot put 6, 7, 8, or 9 in there. Now we have to put 6, 7, 8, and 9 all into these 3 cells. And that's just not possible, obviously, because 4 digits can't go into 3 cells. So therefore, Let's go back. Therefore, this is the opposite of this one. So this must be blue. So what did I say? Yellow must be blue. Let's highlight all the yellows. And yellow becomes light blue. Hot pink becomes dark pink. That's actually kind of fitting. That hot pink and dark pink become the same. Okay. Okay. I thought that would give us something right away, but it does not seem to. I mean, we figured out a bit, but we have 3 blues. This could be another blue. If this was another blue, then these would both be reds. I said this was blue, so this would be red, so these would both be blue. That seems to work. Hmm. Well, we know this cell's... Never mind. I thought we could find out something, but it's literally this one is blue or dark pink, and that's not helpful. I guess I don't know if this is helpful, but these must be 2 pinks and 2 blues. If we look at, so in total, along both diagonals, we should have 8 pinks total and 8 blues total, because there's 4 pinks, 4 blues per line. So 8 and 8 total. We have, at the moment, we have 1, 2, 3, 4, 5 blues total, and oppositely we have 5 pinks total. So in these 6 cells, we have 3 of each remaining. But the thing is that these cells down here are opposite. Are they opposite, actually? Wait, is that necessarily opposite? If this is pink, so if this is blue, do I know that those are opposites necessarily? I don't think so. Okay, well, that wouldn't have really helped anyway, so I can't see how to prove that, but I don't think it actually matters either, so who cares? So we have, yeah. Where can the 4 go down here, I guess? Oh! That's the key. That is the key to the whole shebang. Sorry if you can hear my chair, by the way. It's very squeaky. I think this is the key to the whole shebang. Okay, so where does 4 go in box 9? It can't go in column 9 because the given 4. This can't be a 4. So one of these is a 4. Could we put a 4 onto the German Whisper, though? If this was a 4, what's the only digit that's 5 away from it is 9, and we just said this couldn't be a 9 because it sees 1 and 9. So it can't be there. Similarly, it can't be here. So that means it must be in here. 4 is in one of these. But we've already placed all the blues. Therefore, 4 is going to be in a pink cell. We've placed all the blues, so these last 2 remaining ones are pink/gray, and these are blue/gray. So that means that pink must be low digits. I'm just going to make this a 1, this a 2, and this a 9, and this an 8. And and an 8. And just for sanity's sake, I'm going to swap the colors around because I like thinking about low digits being blue and high digits being high digits being pink, and actually the easiest way is to just delete everything, I think, and restart the coloring. And one of these, and one of these. These are high digits, high digit, high digit, high digit, high digit. I think that's good. Oh, and this must be a high digit, and this must be a low digit. Let's take the 4s off there. I don't need to pencil mark that. This was gray. Okay. So now we can start filling in some stuff. So these must be high digits. So this is 6, 7, 8, or 9. These two can't be 8. So we have an 8 over here. These digits must be, whoops, 1, 2, 3, 4. These can't be 4s, so one of these is a 4. So one of these is a 4. That doesn't, this line right, well, let's look at this first. So this is 1, 2, 3. Again, if we put a 4 here, then this would have to be a 9, so that would break the thing. The difference between 4 and 8 is 4, but it needs to be 5 or more. So 4 is going to go on this line, and it must go with a 9. We're just going to take 9 off of there, and make this 8, 9 over here. And yeah, that's fine. So these are 5, 6, and 7. And I think that's fine. We can't really, this can't be a 5, but besides that, it's fine. Same as over here. This can't have a 6 on it because 6 would require a 1 next to it. So we have 7, 8, 9. So this is going to be a 1, 6, which is going to take the 1 off here and put it over here. Yeah. So the remaining digits here are 3, 4, 5. This can't be a 5. This can't be a 4. So if this is a 6. Well, we need, oh, there's a 1 right here. That's the easiest way to think about this. This is a 1, so this is a high digit. This is a low digit, and probably going to be symmetrical. This 9 is forcing there. It is. These two did turn out to be opposites, but I'm still not convinced that they were, I mean, obviously, by the larger puzzle it was forced, but I'm not sure that it was forced just what we had. But maybe I'm wrong. It doesn't really matter. So what's left in this is, oh, this can't be a 7. Okay, so we have a triple here, or actually we just have a pair here. These have to be low. There's this long short of it. So this is 3, 4, and this can't be a 4, so this is 3, 4. This 4 is looking up, so this is a 1 or a 4. This can't be a 1. So we have high digits, can't be 8 or 9, must be 6, 7. I think that looks good. One of these is a 6, I guess. Because we have 6 over here and down here. I already pencil marked the 4s. 4s over here. Okay. So we need to do stuff with these. So this is a 1, 2, or a 9. Because what's left in the box is 1, 2, 8, and 9. And there's an 8 looking over here. I guess this must be a low digit because it sees all the high digits. And it sees a 5. So this is a 1, 2, or 3. But that's, I don't think, immediately helpful. Let's look at this. So this is a 1, 2, 9. Unfortunately, 1 and 9 are pretty open, and 2 is pretty open still as well. Okay, what could this digit be? It's either, if it's a low digit, it must be a 3, because it sees a 1, 2, and 4. And same for, let's just focus on this. It sees 1, 2, 3, so this would be a 4. Sorry, it sees 1, 2, 4, so this would be a 3. If it's a high digit, it must be a 6 or a 7. It can't be 5 because it's on a line. So if this is a 6, this would be... So if this is a high digit, this must be a low digit, which would be a 1 or a 2. Which would give us a triple here. If it's a low digit, this must be a high digit, which would give us a triple here. Which is a little... more than a little interesting. So let's look here. So if this is a low digit, it must be a 4 because we have 1, 2, 3 looking here. If this is a high digit, it must be a 6 or a 7. And again, it can't be a 5 because it's on the line. So if it's a 4, it must be a 9, which would be a triple here technically, but would also force stuff. If this is a low, sorry, if it's a high, it must be a 1 or a 2, which is again a triple here. So one of these is, could neither of these be a low digit? No. Because either way, so let's say this is high. Let's just say this is high. And this will be a 9, and we'll have 7, 8, 9. So this couldn't be an 8 or 9, forcing it to be low. So if this is high, this is forced to be low. If this is low, this is now a 1, 2, 3 triple, and this can't be a 1 or a 2, so it must be in high digit. So these two are opposites of each other, which means these two are opposites of each other. Well, if these two are opposites of each other, then what? Okay, now I was really steaming there for a second. Steam, I don't know, cruising maybe. And I thought that meant something. If these two must be opposites, that means that 1, 2, 3, and 7, 8, and 9 are accounted for. So this must be a 4 or a 6. Let me think about that. So if this is low, this is a 1 or a 2, so we have a 1, 2, 3 triple, and this is a 8, 9. So now we have 1, 2, 3, 8, 7, 8, 9 all accounted for. Okay, so I'm seeing some things here. So if this is low, we have 1, 2, 3, 7, 8, 9 accounted for. If this is high, then we have the 3 lows and the 3 highs accounted for, which means this has to be 4, 5, or 6. It can't be a 5. So it must be a 4 or 6. So this can't be a 2 because 4 goes with 9, 6 goes with 1. But I saw a little bit more. If this... where can we... This can't be a 7, is basically what I'm getting at. This can't be a 7. If this was a 7, this would be an 8, 9 pair, and then both of these would be low. And we've said that these have to be opposites of each other. Or you could just see that there would be 4 cells that are 1, 2, 3, and 4, which also is an impossibility. So this is not 7. And actually we can take, and now we could look at where can 7 go in this row. It must be here. The way that I saw that is that this must be 7 no matter what. If this is 9, this is 8, this is 7. If this is 8, 9, this is an 8, 9 pair, and this is 7. But yeah, either way that works just fine. I guess this is a 5 or an 8. I can pencil mark that. It doesn't really do much. This is a 2, 3, or 5. That doesn't really mean much either. Okay, whatever. Let's get back to right here. This is the important part. So if this is 4, this is 9, this must be 6, 1, then this is going to be a high digit. This must be a 7, and this must be a 1 or a 2. Does that really... that makes this a 6 because it's the only place for 6 in the row? And this is a 3 and this is a 5? Okay. So if this is a 4, this is a 6. I'm not sure how helpful that was. Okay, what if this is a 6? That seems like a decent place to look. So this is a 6. This is a 1. These can't have 6 on it, so this must be a 6. This must be a 5. But still, that does it. Just makes this a 5, but that doesn't really say much. This is 3, 4, or 7. It definitely reduces options all around, but doesn't really give us an answer. I guess one of these has a 6, 7 pair in them, but we don't know which. Not sure if that's helpful. Oh, there's a 6 right here, so this is 7, so this is not 7. So that little bit about, like, this couldn't be 7 because it would break the puzzle, that was just not needed. This is, oh, there's a 4 here, literally a 4 here. Okay, so this is, oh my gosh, okay. Brought to you by me making this puzzle harder on myself than it needs to be. This can't be a 3. Which I guess I probably could have told because there's a 1 or a 2 here, so the 3 must be over here to complete the triple. So neither of these can be 6. So this is a 3, 4, 7 in the middle. So this must be a 6. This must be a 1. So this is a high digit. This is a low digit. These can't be 1s. This can't be a 7. Because one of these has to be a high digit. I've said these are opposites. So one of these are high digits. One of them is going to be a 7. Okay. So one of these is a 7, one of these is a 7, so one of these must be a 7 because we can't. This is kind of an X-wing. I can explain that real quick. So we've locked 7 into just 2 options in row, in column 4 and column 6. So what that means is in the final puzzle, once we've finished the puzzle, either this will be a 7 and this will be a 7, because this 7 forces this to not be a 7, so this has to be the 7. Or this is a 7, which forces this not to be a 7, puts the 7 here. In either case, all of these cells can't be 7. All the gray cells can't be 7. We can look at what happens if we try to, do the opposite. Put a 7 here, that forces this to not be a 7, so the 7's here. But then also in row 8, this can't be a 7 because of the one we just put in, so this must be a 7. But now we have 2 7s in the column, and the puzzle's broken. So these gray spots up here can't have a 7, and let's do that. So these can't have 7. We also have a 7 up here in row 1, so all that's left is right here. 4, 9, or 7, 1, 2. Two and 3 are in these 3 cells, although 3 can't be here. Because we have 2, 3 down there, or up there, and 2, 3 down here looking into box 6. Sorry for my squeaky chair. It is really squeaky today. I don't know what's going on. It's a lot squeakier than it was even just a couple hours ago. I feel like there just must be basic Sudoku that I'm missing. Oh, yes, there is basic Sudoku that I'm missing. This 5, where does 5 go in box 1? Must go in here or here because it's ruled out of there. This 5 looks over and puts an 8 there. But more importantly, or at least as importantly, the 5 is looking down in box 3 because it can't be in this part of the cross. So it must be looking down. No, a 5 looking down. Sorry, a 5 looking up, a 5 looking down, a 5 looking over here. So this is a 5. And now we have a 5 in one of these spots. Then we have a 5 in one of those, which isn't as helpful. But we know this must be a high digit now because it can't be a 5. So this is a 6 or a 7. Because we already have the 8, 9 there. So these both must be low digits. Which must be 2, 3, 4. And this can't be a 4 because of this. So now we have a 2-3 pair in the row. So this must be a high digit because it sees a 1, a 2, 3, and a 4. And it also sees a 5. So this is a 6, 8, or 9, and it can't be a 6. So this is just an 8 or a 9, which gives us an 8, 9 pair. So what's left in this row? We have 5. We have 1, 5, and 6. This can't be a 1, so one of these is a 1. I don't know if that's hugely helpful. Let's get rid of some of these pencil marks. I don't think they're helpful. This is a 5, 6, or a 7. Yeah, I don't need those pencil marks anymore. This is a 2, 3, 4, or 5. I guess this is a gimme, isn't it? This is a 9. Oh, that's helpful. That's really good. So these can be 9s. So this is a 9. Which makes this an 8, this a 9, this an 8. 9s are over here somewhere. We have 1s in here somewhere, just the 1s looking in to the box. Not as many 1s looking in over here, unfortunately. Oh, 9. Where does 9 go in this box? It can't go along here because of those. It can't go down here, so this is just a 9. What 9s do I have left? I have these 2. I have these and these. This could still be an 8, unfortunately, which will put a 9 here and give us some leeway. Otherwise, we could force 9 into here, and then this would be an 8, 9 pair over here, but yeah, we can't quite do that. This is a 2, 3, 6, 7. Is that worth typing in? I don't think so. This seems pretty restricted. This can't be a low digit, and it can't be a 5, so it must be a high digit. It can't be low because it sees 1, 2, 3, 4. Also sees 5. So this is a 6 or a 7, which then pairs up the row. So this is just a 2 or 3 remaining. So that's a 1, 2, 3 triple. Actually, this is just a 2, 3 pair. So this is a 1, which puts a 1 in here, which means 2 can't be in here anymore. Or we could just use the fact that this is a 2, 3 pair. Either way. So this can't be a 2 or a 3 any longer. This is a 4, 5, 7 in the column. This can't be a 5. This can't be a 4 because of the 4 and the 5. This can't be a 6 because there's a 6 right here. Although I'm saying we now have a triple, or we've had a triple here, a 5, 6, 7 triple. So this is a 1, 8 pair. Oh, and there's 8s looking over. So this is a 1. Whoopsies, that's not what I wanted to do. There's an 8 here, so there's an 8 in this pair looking over, so this is a 1 or an 8. And actually, this can't be a 2 because of the 2, 8 pair as well. This is still 2, 3, 6, 7. That's not helpful. 1. This can't be a 1 any longer. We now have 1s looking in all over, so this is a 1. The last remaining spot for the 5 is there. We're just going to put a 5 there. This must be a 4, not a 4. 4, not a 4. And let's color these real quick. This is low digits. This is a high digit. This can't be a 2, actually, because of the 2, 8 pair. So this is going to arrange a few things. This can't be a 3 any longer because the 3 we just put in. This is a 6. This is a 7. This is a 6. This is a 3. I took that pencil mark when I removed the 3 from there. Or I removed the pencil mark here when I put the 3 there. Yeah. This can't be a 6. This is a 7. This is a 6. This is a 7, 5, 6. Let's take a coloring break. And this is gray. Okay. Oh, this can't be a 7 now. We have a 7 looking down. So this is a 3, which is making this a 4. This is a 7. This is a 1. This is an, whoops, this is an 8 or a 9. Let's color those real quick before I forget. Could this be a 2? This could be a 2, and it could also, no, it can't be a high digit or a 5. So this is the 2. So this is a 5, 8, 9 triple. That was just scanning. This sees a 6, 7, 8, 9, and a 5, so this must be a low digit. What's left in the column is 3 and 7. Not resolved. Not resolved. Although it will be in a second because I just noticed we have this diagonal here. We put a 3 here. This is a 2, this is a 3, this can't be a 2, so it's a 3, 2. And this 3 looks over, making this a 7, 3. And actually, I guess we had 2, 3 pairs all along here, so this couldn't have been a 3 anyway, whatever. Okay, can we finish anything? I think the diagonals, no, the diagonals aren't done. This 8 looks down and resolves our 8s and 9s over here. We have an 8 here, which resolves that. We have a 1 and a 6, which makes this a 5. This is not a 5 or a 6, I guess, so this is a 1. Low digit 1. These are both going to be 5s. Whoops, these are both going to be 5. These are both going to be 5s. We'll just keep saying it until it's true. This is a 9. Oh my gosh. This is a 9. This is a 4. I'm really good at clicking in between the buttons on the keypad. This is a 2. This is a 6. There we go. Let's finish the puzzle. Or finish the coloring. And there we go. That was probably like a 2.5. Yeah, 2 to 3 is a good range for that, but I think it's a little bit easier than a 3. Probably like a 2.5, maybe into 3, but I don't quite think it is a 3. Maybe, I don't know. It's so subjective. It's hard to tell. It doesn't really matter anyway. Yeah, I really enjoyed that puzzle. It was great. I'm not super comfortable with German whispers, so it was nice to do a German whisper puzzle and then be able to get through it pretty smoothly. But yeah, I had a lot of fun with that. Thank you, Jeet Sampat, for the puzzle, and thank you all for watching.